Hello, good afternoon dear friends. Today we are going to discuss about intersection of solids or interpenetration of solid. Means what? When two types of solids intersects each other, then what should be the curve of intersection? That we will discuss today in our session. First, what is intersection of solid? When one solid penetrates another solid, then their surfaces intersect. At the junction of intersection, a typical curve is formed, which remains common to both solids, and this curve is called curve of intersection. When the solid is of having straight line nature or straight surfaces in nature, the curve of intersection would be straight lines, and when the solid having a nature of curvature shape, in that case the intersectional view will be curvature by nature. Today we will discuss about prism, pyramid, cylinder and cone, intersection of various solids with given condition, and it is the result of interpenetration of solid. So one solid interpenetrate to the another solid, and that is the intersection of solid. This is the view of intersection of solid. You can see here two cylinders are there, both are at right angle to each other, and another is the cone. Here a cone is there, and this is the intersection of solid and plane. An intersection of solid and plane we had discussed in other earlier chapters. Here we will discuss about intersection or penetration of one solid inside the another solid. Intersection is the point or line where two geometric forms such as lines or surfaces meet or cross each other. You can see here in this example a surface crosses the solid, and here one solid is crossed by another solid. So this curve, this curvature shape here as well as here. Similarly, in this case this curve is called intersection of solid, and this case is called penetration of solid. This vertical cylinder is penetrated by this horizontal cylinder. So this cylinder, yellow colored cylinder, is called as penetrating solid, and this red colored cylinder is called as penetrated solid. So we can say here vertical cylinder is penetrated by a horizontal cylinder over here. Why should we discuss all these contents? What's the importance as far as mechanical engineering is concerned? So for this I have shown here two examples. In this example two square pipes are there, and here circular pipe and rectangular pipe are there. Here minimum surface contact is there in this condition. If we join these two pipes, here minimum surface contact would appear, whereas in the second case maximum surface contact is there if we join these two square pipes like this, and here cylinder like this. So can you imagine the difference between these two conditions? Which condition can be employed in which kind of cases? Means when the surface contact is to be minimized, we should join the solids like this, and when the need of maximum surface contact is there, we should go for this option. So for example, when the surface contact is needed, for example frictional losses, in case of less contact area, less frictional losses would be there. Here frictional losses would be lower, here also less frictional losses would be there, but in this case loss of friction would be higher. So in which condition this situation is employed? When the strength is the criteria, or we need to join these two pipe. At that time more contact area should be there, and in those conditions this second condition is employed. Now some examples of intersection of solids. This is one example: a machine component having two intersecting cylinders with the axis at acute angle to each other. Here two solid cylinders are there. This is one cylinder, another is this vertical cylinder. Or say two pipes are there. Two pipes are intersecting over here, and here curve of intersection would be there like this. So this is one example of development of intersection of solids. This is another example: an industrial dust collector. This is an example of intersection of two cylinders. This is one cylinder, circular hole is there, another pipe, it is bent over here. So number of cylinders are here, one is here, one is cut at certain angle like this. So this is another example. The next example: intersection of a cylindrical pipes, main and branch. Two pipes are intersecting each other at certain angle. In case of steam supply pipes, this kind of conditions may occur when steam is to be separated by in two segments. Then another example is pump lead having the shape of a hexagonal prism. This is the shape of hexagonal prism, and hemispherical, this is hemispherical shape. Both are intersecting each other. So this is also an example of intersection of solid. Then this is a practical example, which is forged end of a connecting rod, which is used in compression in IC engine to connect piston and crankshaft. This is a big end of the connecting rod, and this is also example of intersection of solids. Another very good example, a feeding hopper, which is used in industry. Hopper is there. This is intersection of, this is a frustum of pyramid, and this is a cylinder. So that is used in industry as a hopper. This is the view of cylinder-cylinder intersection. When two cylinder intersects each other at right angle, and if we cut from the upper face like this, then its top view would appear like this, circle and these straight lines. So this is intersection of two cylinders, and this curve, this is the curve of intersection. This is another example of cylinder and cone intersection. A cone is in vertical position and cylinder is lying in horizontal position, and this curve is curve of intersection between cylinder and cone, and this sectional line shows the true shape of the section. Now we take various cases one by one. First case, cone and square prism having both axes vertical. This is the data for such kind of problem. A cone, base diameter 70 mm and height 90 mm is completely penetrated by a square prism from top with its axis parallel to cone's axis and 5 mm away from it. A vertical plane containing both axes is parallel to vertical plane. Take all faces of square prism equally inclined to vertical plane. Base side of prism is 30 mm and axis is 100 mm long. Draw projections showing curves of intersection. So in this kind of problem, first think about which type of solids given to us. Here cone, this is cone, and another is prism. Cone and square prism are given to us. And then first we draw any one solid. Which solid should we draw first? Generally the solid which is penetrated, that should be drawn first. So here cone is the solid which is penetrated, and square prism is the solid which is penetrating solid. So first we draw this problem. First this is the view of given condition, cone and a square prism. So first we draw XY line which represents intersection of HP and VP. Then after name XY line, draw a circle of diameter 70 mm. This is the top view of given cone. A cone is resting on its circular face and its top view would be a circle as shown over here. Then after divide this circle into equal number of parts, say A, B, C, D, E, F, G and H. After dividing into equal number of parts, let me take projections from each point in the vertical direction like this, and then draw a triangle having height is equal to 90 mm, because height of this cone is given as 90 mm. So this is the front view of given condition. So we have drawn one solid. Now we have to draw this square prism. How to draw this square prism? So for that, read this statement. It is penetrated by a square prism from top with its axis parallel to cone's axis. Means axis of this cone is parallel to axis of this prism. So we have to draw another axis parallel to this axis over here, and the distance between both the axes is 5 mm. Means what? Means that from this axis, the axis of square prism is at a distance of 5 mm. Name these points, and at a distance of 5 mm from this axis, mark another axis, and from that axis draw a rectangle like this. This is a square because it is given that in the top view all faces of square prism are equally inclined to vertical plane. Hence this square should be drawn like this. All faces or sides of this square makes an angle of 45 degree with XY line. So if I draw line over here, then this angle would be 45 degree. After drawing, this is a square of given side length, that is, what is the side length of this given square? 30 mm. Draw this square of 30 mm sides. This distance, offset distance, is 5 mm. It is given in the data. Now find out points of intersection between these two solids. One point is here. If I draw vertical line from here, this is the point of intersection on OG, on OH, on OA, on OB, OC, OD, like this, OD, OE and OF. So these are the points of intersection between the imaginary generators drawn over the cone and square of square prism. Here, how to locate these points? As we have drawn here imaginary generators OA, OB, OC, OD, OE, OF, OG and OH. So intersection of OA is one point, intersection of OB with this line is another point, intersection of OC and so on. So mark all these points over here. Now we have identified the points of intersection between these two solids. Another point over here. Name these points 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. We have identified 10 points which shows the intersection of this prism and cone. Now how to locate these points in front view? So for that, first we draw vertical line from this point 1, vertical line from point 2 which cuts OB at some point, because point number 2 is on OB. From on OC, point number 3 is there. So from this point 3, similarly point 7 is on OF. So from point 7 draw vertical line that will cut OF at some point. From 6, from this point draw an imaginary generator. How to locate this O1 point? So for that, draw an imaginary generator which passes through this point, point number 8. Means join 8 and center of this cone with a straight line, extend that line, and from that line transfer this point to its front view. So this is an imaginary generator drawn in the front view. Now from this point draw straight a vertical line, and that will cut this line over here. Mark the points of intersection like this, 1, 2, and here similarly this point O3 is over here. So how to locate point O3? So for that, draw an arc like this. This exercise we did earlier also. Cone, the center of this cone as a center, O3 as a radius, draw an arc. From here draw vertical line, and this vertical line will cut this imaginary generator or this end generator at one point, and from this point draw horizontal line that will cut this axis at one point. Mark that point. So this is another point of intersection. So you can see here this point we have identified over here. Similarly this point is identified over here, and this end point is identified over here. Now we have to worry about rest all these curves, and for this curve we identify this point as well as this point. So for that, mark the points over here, 1, 2 and 3. This is the point of intersection of this prism and cone. This is this point. This apex point is here, uppermost point, and this is the point. And then name all these points from transferred from top view. So 1 dash, 2 days, 3 days, 4 days, 5 days, and so on. So respectively name all these points 1 days, 2 days, 3 days, 4 days, 5 days, 6 days onwards. Now join these points with a smooth curve, because this is a cone. So this is the point of intersection or curve of intersection. First, this is second curve of intersection and another curve of intersection. So this is the final answer. The curve of intersection, this curve, this we have drawn over here. I think it's clear to you. Now this dotted line shows this edge. This edge is inside this cone, so it will not be fully visible. So we join with a dotted line. This line would be solid line as shown over here. This line would be solid line.